So in the few last classes we have seen like load operator, how to load the data into a relation. A relation is nothing but, as I said before, it is a flow language, right? So a relation is nothing but a table. It looks like a table. So how it looks, let me show you here. See here. So I have some data. Okay, that data I want to load into some table. So in the Hive we have something called, we'll create a table and we'll load into the table, correct? So here the same way I'll declare the variable x equal to load, and I'll give the path of the data where my data was there, and I will using, there are different kind of storages like a storages means. And so in Hive we have something like a row format, delimited, comma, something we will use, right? Fields terminated by. The same way here you have something called some storages like a pick storage, and we'll delimit by comma slash t, whatever it is. Okay, and as we will write our schema here. So schema means our columns, call column data type, again call column data type, like that. So this is now what will happen, this x is nothing but it's a representing called a relation. This will call relation, this is called relation, or this is called a bag. So to see the data, whatever the data is there in the relation, what we will do, we have some operator called dump x. As soon as you say dump x, it will just bring the data, it will just load the data into x, and it will put into the screen. You can see inside the in when print into the screen, you can easily see that it will be in the table format because you have already specified it. So my data is the tab separated. You take the data. After taking the data, you put first field into the column 1, second field into column 2, and so on, column n, right? Based on the data type, based on the data it appears, the data will be internally divided, and it will be kept into the different fields. Okay, so now your table will be created. Suppose if you want to do any operations on these relations, you can do that operations. Like you can do a grouping by. Suppose you want to group by some specific element, you can do a group by. Suppose you want to do minimum maximum for some value, you can do it. And you can also store them, you can also use whatever the result comes, right? You can also store the result into some specific location. So let's see some examples. So, we have seen some example yesterday, so we will be continuing with them. Let's have a little look of it. So as I said before, there are two modes in pig. One is the local mode, other one is MR mode. So to run in MR mode, you need to running your cluster. Your cluster should be running, and to run in the local mode, you don't need to start the cluster. But I have just started the cluster, so we don't need to worry about it whether it's running or not. We don't need it because when you're going to execute in the local mode, you don't need to worry about the cluster. Okay. So to launch in a local mode, pig-x local. So if you launch in a local mode, the input path and output path you can give as a local. The input path, the data, whatever the data you're loading, the data whatever is storing, so that will be in the local addresses only. But when you launch in MR mode, that whatever the data you are loading, whatever the data you are saving, I mean I can say output, that the data will be in a HDFS mode. Clear? Okay, so let me open. I have some already I have some classes what I mean actually we were doing whatever we are doing, right? So I'm keeping in a specific location here. um, Let me open speak classes, speak 530 classes, speak final training and sample programs. Okay, UDF, big UDF. Okay, so this is what we are trying to do. Where is our class? This is our classes, right? Yesterday last class what we have done, we have loaded the data, and some data we have loaded in the year and temperature by taking some data. We group by the temperature in by year, and we found the maximum value, right? Max of that value. We found the max of the temperature year wise, right? So and also we have loaded some data and we started searching for that data. That's kind of a grep command. So we have used grep in last class, right? The same way we have used the grep we did. So not only this example. So suppose you want to find, let's say, the count. Okay, so how many I have some URL data. I want to find the count of it. I want to find the count of it. So total count, average. So each URL, how long it is performing. So let me take some example of data, some sample data. Let me take. So let's say I have some data here. I think this is a very big data. I mean, little no, huge data here. So I have a URL and count, and you have URL and count. How many times the URL has been hit? Okay, the URL has count. Now I want to find which URL is more visited. So who is visiting for the specific URL more times, and what is the average? So average time the people are logging into specific URL. Okay, so how we will do that? Any idea? So based on last classes, you guys can tell me how we will do that. How we will do that? So my requirement is I have a data URL and I have something called count of URL. How many times it has been up? How many times it has been repeated, and what is the average? What is the average of it? What we will do? Okay, let me write a sample example here. Okay, first we will take your URL log file. We will load the data. Correct. We will load. We'll give you the path. And anyway the tab separated, so by default it will be tab separated only, or if you want you can say using big storage. This is big storage is a uh, big storage is the case sensitive, guys. Big storage, it is in a tab separated /t as. So we are specifying the schema explicitly here. What is the schema? URL, you can say it is a string, comma, and count, number of times occurs. The count or number of times occurs. Okay, URL count, number of count, int, right? This is my schema. I have defined it. So now I have loaded the data. After loading the data using pig storage, I have created a schema for this. Now what I need to do, my requirement is I need to find average of the each URL has been clicked. What is the average time for each and every URL? So what I will do here, I have loaded the data. So let's take, I'm not taking the path. Let's take some path here. Okay, I will give the path. So first I'm explaining how it will work. Now what I need to do, so now I need URL wise, right? So I need URL wise. What I need to do, I have to group that, right? I need to group the URLs. So URL 1, how many times it came? URL 2, what was the data? So I will first group by the URL. So I will groups the URL. So after grouping URL, what I will do? Then I will go with our average or sum or whatever the operations we want to do. First we will do by URL. So group, I am going to do a group, and where URL log by, so the URL log is nothing but what? Your relation, your complete table. In the table, grouping the table by specifying by URL. So I want to URL wise, right? That's why I'm doing by URL wise. Are you guys able to follow? Right? So after this URL, what I will do, for each URL, how many times the average, right? Each URL, what is the average time it has been clicked? Each URL, what is the average it is clicked? So I can say URL avg. I need to find average, no? But for each URL, first I have loaded the data into, one is URL comma count. Second one is I have grouped by the URL. The third, now I need to find the what is the average. So for that, for each URL you have to go to, correct? You have to go to for each URL, right? For each URL, what we will do, for each, you have something called for each in URL groups. Each URL is do a groups. What I need to do, generate group. It's a syntax, guys. Generate group average of where I'm going to find the average. So I need to find the average on where? Count, right? I need to find average on count. So my count is what? Like a table dot column name will give, no? URL log dot URL log dot URL count. I want to find this average. So I can give alias name as URL avg. Okay, so already I have taken that URL. Uh, I can take something different name. URL wise avg. URL wise avg. So now what I have done, for each URL, I'm finding the average. I'm putting into some variable. I'm giving alias name for it. So what I'm giving, why I'm giving alias name? Later, I may I may put into ascending order, descending order. I can do that. For you can find ascending order. If you want to bring last to 10, you want to bring top 10, you want to bring last top 2, based on the average we can do it, right? So for that, first we need to find the your data. Where is the URL count? URL count, it is there in desktop, right? Let's go ahead and give the proper path here now. /home Hadoop 1 desktop /Vera /pig /URL count.txt. So we know that it is a case sensitive. We need to give the complete name. Look at, guys, here. So first time, why I'm writing into the text pad. So if any mistake is there, something has to be changed, we can easily change instead of directly executing the terminal. Something went wrong here. Syntax, unexpected symbol at all, string. Sorry, here we don't have a string, char array, right? That's the problem with confusing your char array. We don't have strings here. It's a char array. Okay, it is created. It is created. Now table is created. You want to, if you okay, suppose if you want to see, I think I have something called URL limit. I don't think this is supported here. No, the dump is completely dumps. It does not have any aggregation function. So why I'm not dumping that? If I start dumping, it will show the huge data. So it will take so much of time. If you want to see, you can see dump URL lock. It's a very no, so many rows are there. So it will start dumping all the things. See here, each and every URL it started dumping as a two columns, tuple, as a tuple, right? So this complete tuple is nothing but your output. Okay, I'll just break it. Okay, otherwise it will keep running. So I'm just broken it. To show you that how it will load. Okay, I have taken the raw data, but it loaded into tuples. See here, all these tuples, collection of these tuples is called bag. Collection of this tuple is called bag.
How you stop that, Ravi? Control D or something?
Control C only, normally, how we will do in the control C command.
Okay.
Okay, now let's go with the next one. We're grouping each one. Okay, now the groups has been made. So URL wise the group has been made. So these will be less amount of numbers. We can see that. The data was the previous I was shown the data. It's a more number of records and it is copy pasted data. So that's the reason it was taking so much of time. You can take any data, guys. You can take any data. So you can download uh, you can download some data from your Yahoo Finance. So you'll get the stocks data over there. So I have did it. I will show some examples in my local. Okay, I have done it. So by the time it loads, let me show you some big data which I already did for some stock data. You can see here ticks. Ticks means your stock. I think it's a little slow. Hmm. We can also do some POC. I'll give this one. We'll see that later. No, it's taking some time to load. I think let it load. By the time we'll go on. Look at here. See here the average, the group. So each group is coming here. Each group, the group, and see the URLs multiple times it has been copy pasted, right? So that's the reason. If you see, if you see here, the group one element only is a grouping same. See URL 19, URL 19, URL 19, URL 19. These are all are URL 19 only because it has been grouped by each part, right? So it is grouped. Now let's see average for each and every element. Dump. I mean first load, then group by. Then we will do for each average. For each line, how many times average? For each line, what is the average? URL wise, what is average? Semicolon is required. So dump URL avg. It's loading. See guys here, almost similar but little difference is there because it's copy pasted data. As I said before, URL 1 2 3 4 5, first we have created 20 URLs, then we have copy pasted the same data multiple times. So that is the reason the count and everything almost similar, but you can find here 145.58 the 56, and few URLs are multiple times are there, more times are there, few URLs less times are there. You can see this properly, it has been averaged, found it or not. So what I have done here, see if you see the first URL, it does not have any value. It means that there is some URL which does, we started with http colon slash slash, that's nothing, is no count for that, right? We are able to find out the difference. So now what we did, we loaded the data, we grouped it, and we found the average by specific URL. So now I want to bring the I can say which is the maximum word. So I want to bring the maximum, or not maximum, I can say ascending order, descending order. I want to sort it. How can I do? Sorted, URL sort. So already I have a URL, already I have a average wise URL count is there, right? So now what we can do, we can just order it. So there is a command called order. There is a command called order. You order it. You order URL average. You order the URL average by by we already written here, no? We already written alias name, right? So now see, actually you have only two columns. One is the URL and count. Now if I want to do average by specific column, whatever the column I have created as the average, I'm going to use that column. So whether you want to do it in descending order or ascending order, we need to specify, right? We need to specify this, right? So I'm specifying this. Let's look at. You can dump it. Dump URL sort. URL sort. See here. Now it has been sorted based on the descending order. Descending order means the bigger value will come first. See here, before when you see the empty value came first, but here empty value came last. See here, by default it is ascending order, no? So we know it. By default it is ascending order. When you dump it, it will show the ascending order. So now see here, 145.73 is the first place, 72 is second place, dots 59 is third place, and so on. If you see, even though we are not able to find out with the 145 the value, but still we are able to find some difference in the no, uh, it has been properly sorted in the descending order. Understand? Any doubt? What are the commands we have seen? We have seen group by, we have seen for each, we have seen average, we have seen count, right? We have seen a loading, right? So these are the different operators. Now we're going ahead and see some more operators, right? So we'll go ahead and see some more operators. Let me save them, and I have some data, input and output. I want the input and output files. I'm looking for it. Let me look at, I have some any input data here, sample.txt. Okay, so we know the set program. So now we have seen all grunt. Okay, now we are going to see how to uh, if we find, do you guys remember set program? What is a set program? Set program, sed, cd. Sed means find and replace. Yeah, I have stock data here. This is what I was looking for. I have a stock data, so I can do more operations on using the stock data. I think by the time my this also might become up. Yeah, this is the one. This is the one. So where I am loading some NASDAQ data. So on the top of this NASDAQ data, we are doing some operations. So now we are going to do the same kind of operations. We are going to see that now. So all these operations we'll see. So it's kind of small POC. It's kind of a small project. I can say where I'm loading the data. After loading the data, I'm finding for each like after loading, what is a distinct data? What is a distinct ticks? Okay, and finding out like a cleaning up the empty records. So empty records should not come. Your empty record should not come. So we have to clean up the data. So how to remove the cleanup data? How to group by each tick? Remove the duplicates. So you may want to remove the duplicate records. So how to remove the duplicates for each? I'll share this, guys. We have done a very small POC kind of thing. And after that, which for each tick, what is the minimum and maximum? How to find the minimum and maximum, right? Minimum value and maximum value for each tick. And after the tick, we can also store directly into HBase. We can also store directly into HBase. How to store directly into HBase? Some other database. The result for each symbol, generate average for open price and close price. I'll tell you. I'll explain the data set. Then you will easily understand. Okay, this we will discuss little later. By the time let us get familiar with some more what we call the operations, then we will see them. I'll explain. This is the data, NASDAQ. This is the data we are going to see. We are going to play with this data. I can also show you something, my final training. Yeah, let me take this one. Yeah, let's take this simple data. The data is like URL. I mean, this is the user, how much time he has spent it on specific query. Okay, this is my data. I think this data already there. Let me check. It is some transaction data also there. I need this transactional data. User and user page. This is some data, guys. This is some data, and I want to show you some other examples. I think this is what we have just discussed, URL and count. This is what we have just did. So what we did, here we are using like this is a batch mode. So whatever we have executed is a grunt mode, right? Whatever we have executed grunt mode, and you can also execute using batch mode. Batch mode. So what is a batch mode? Okay, let's see the batch mode example. So look at here. This program, I think this is already this program I'm going to execute as we have seen yesterday. We have seen yesterday this one, word count matches. This one, not word count, it's a matches, right? We have seen this yesterday, right? So what we have seen in this yesterday, we tried to find we tried to find matched words, right? The word whatever is matching, we did it in a grunt mode. So now we are going to execute it as a batch means nothing. You keep all your statements in a single file, then you execute that file. Okay, then how to execute? Let's look at, guys, that this is the path. It is there in Vera, right? Already in grunt mode. Let me go out of this. I'm opening the new X local, and I want to find where is the file path it is. Okay, now I need to go to specific path. So let's say hyphen param, because I need to see. Okay, let me show you. One is a hard coded one. Let me show other one is not hard coded one. So whatever we have did yesterday, that one I'm going to show you without with a hard coded value. Grep dot pick with okay, let's say just grep 2. Just go to desktop, Vira pick. I'm going to save in this. Let's try to execute that program. Yesterday we have seen, no, that same program we are going to execute now. So that's there in home, Hadoop, desktop, Vira, grep, pick, grep 2. Okay, this is the program I'm going to execute. This is the program I'm going to execute. Let's look at, guys. It will load, it will start executing all the statements. It will start executing all the statements line by line, and finally it will dump the results. But to dump the results, it is dumping in our console. Normally in the real time, we will not dump in the results in the console. We will store into some other location by using stored into. See, guys, here it's brought the result. This guide shows. So that whatever the data we have loaded, the data has a that value. The matching value is there. Now I don't want to hard code. I don't want to hard code. I want to give. I don't want to hard code. I want to give the at the time of execution. I want to pass a value. I want to pass a value. Let's take this is an example. Okay, this is also hard coded one. This is also hard coded one. Okay, let me. Okay, our first grep program is not hard coded. This one, our first program is not hard coded. So we are going to execute it here. How not to hard code? So normally how you hard coded here? Here you specify the matches and specify the value. You specify the matches and specify the value. Now I'm not going to hard code like a Spark. So based on my input, my data has to change. Based on my input, my output has to change, not the input. Based on my input, the output has to change. How will I do? There is something called hyphen param is option, and this is the variable arg. The which variable which you are going to use in your program. So here I'm using arg, $arg. So I'm going to execute this grep program by passing the one time I'll pass some other name, one time I will pass some other name. So first let's see what is the data is there in it. Try to see first what is the data in it. First we need to understand the data. Let's understand the data. Look at here. The data it contains something like why it is cat loaded and all. Oh, sorry guys. It's not copied properly. It was copied complete X, including X it is copied. That is the reason it is being no error. Yeah. Hadoop is open source. I mean framework is a big data something, right? So in this name, do we have anything called Veera or Ravi or something? Is there anything Ravi with the same? No, Ravi is not there. So I'll be passing Hadoop while executing this. I need to specify. What is the param? Param. So arg, because in the program I have used arg. So here I'm saying Hadoop. Let's look at. It should bring what wherever the Hadoop is there. What are the lines Hadoop is there? It should bring and show me. See here, Hadoop only two lines is brought because only two lines has the Hadoop. Only two lines has the Hadoop, right? So this is how we will execute the batch mode. That's how we will execute batch mode. Let's look at. Okay, then we have executed this. Just remove filter command. This is how to matches, how to filter just by using filter command. Okay, remove this. We don't need it now as of now. So we are going to see some more example from this. Okay, let me take, this is my input. This is the user ID. This is the time he has spent under some specific query. He has given some query and is waiting for the query response. So now what I need to find out here, so like for each query, how much time, for each log, what is the count, what is the count of each query, the each user. So one user, how many times he has logged some queries. Okay, so let's prepare the data for it first. User local, I don't think there is something called pick data. There's something called pick data. In this, yeah, same data with the tab separated, guys. This is the same data with the tab separated. I'm taking two more lines of code. We can change some numbers somewhere here. Okay, now I want to find, okay, save this data. So this data, what I'm going to do, I'm going to find, I want to find in this, for each user, what is the query, I mean what is the count of each user query. So based on the user, what is the query he want to do, what he has done. Let's close this as well. This word search, yeah, we came here. So we will write our program. This also as of now we don't need, we will see later these things later. We'll just type here itself. Write a program here for each user, for each user. So here let me say count the uh, number of queries for each user, for each user. So what is the each user, what is the query, number of queries for each user, right? So now what we need to do, first we need to load the data. User log, you take user log. Where is the file? It is there in my load, is there the slash usr slash local slash big data slash url count, user count or url count, it is url count dot txt. So do you want to write your own storage? Yes, you can go ahead and write. Otherwise, if it will by default it will take as a default schema. But if it is take the default schema, the default data types will be char array, byte array. Suppose if you specify the data type, fine. So here I have specified int. Okay, I can do min, max, average, anything on this. If it is default, if I didn't specify the column names, if I go with the automatic schema, it could have been char array, char array. Sorry, byte array, byte array. If it's a byte array, it's difficult to do a sum, right? So I'm going to do using pick storage. If you have already seen, the data is tab separated, as we have three columns there, right? One is user, which is char array, and other one is time. He has spent, how much time he has spent. You can also take it is a long, and other one is query, char array. This is a first line of statement which we loaded the data. After loading the data, what we need to do, each group, it means each user, we need to group by the user group the user. Are you guys able to follow? I'm not getting any response from you guys. Akash, Anila, Devasis, Sunil.
Yes, Ravi.
Okay, I see Srini, Sunil. So now I'm grouping by each user, right? So what is the command to group? Can someone tell me? Anila, what is the command to group? Akash, what is the
Group name by user.
group? Not group name, it is your relation, the first relation where you have loaded
Mm,
by
okay.
which column you want to do. Which column you want to do? I want to do column by user column. Okay. So now I bought the users. Now what I need to do? I just need to find the count, user wise count. User wise count. What I need to do for user to get the user wise count? For loop. For each I need to do. For each user I need to find the count. See, okay, first let me show you what's happening here. Shell is for guys to execute and check whether your commands are correct or not. Okay, in the real time we will not be using I mean, it doesn't mean that we will not, in the production we will not be having shell. So what will happen in production? All the statements will be executing in the batch mode, right? All the statements will be executing on the batch mode. The shell will write for whether our statements are correct or not, then we will make it uh, batch mode. Then we will write. Let's see what is the group it is did. See guys here, this guy came one time, this guy came two times, excuse me. This guy came two times. Here you can see the tuples. This guy also two times, and this guy is three times, three or two times, and this guy one time. So it's grouped by each user. This is user. This is grouped by each user. Now we need to find the count of user wise. So if it is to find the count, so nothing here. So what we are trying to do, see, the groups are formed, right? The groups are formed. We are going to count this form. Okay, only one time. One tuple is there one time. Two tuples are there two times. Three tuples are there three times. So we are going to count this count. Okay, for each, what we are going to do for each user group. Oh, user group, right? For each user group, generate. It's a keyword. Okay, group, comma, generate group, comma. So what we need to do? We need to find the count of count of what? queries, right? How many queries, right? Yes or no? You can find queries or you can find complete URL log. Why it is not pasted? So now I'm going to find each group how much count is there. Each group how much count is there. Dump user count. See here, the user 1 came one time, user 2 came twice, twice, one time. So this is how it has been counted. This is how it has been counted. Okay, and I request you guys to don't simply dump every time. You guys need to use something called stored as. Stored, this count, the final output, your user count, into where you want to store. You have to specify that path. You have to specify that path. Slash usr local slash usr slash local big data slash, the output file is url count. It will be a folder, guys. It's not be a file, it will be a folder. Correct only, no? User count, correct only. Something went wrong. Look at, guys, here something went wrong. Any path or any store. It's not store, it's stored. Store, yeah, store. It's not stored. Okay. Now go ahead and look at into your big data. URL count directory has been created. Inside that you will be having some part file. Go and look at the result of this. You got the result. And also while loading the data, while storing the data, guys, you can also use a quick storage delimiter. Here by default it came tab. By default delimiter in pig is tab. Guys, try to remember this. Okay, so this by default it is taken as a tab. Now I don't want the tab, I want to specify something else. You can specify that. Okay, so that's it for today. Some examples we have seen today, some of operations like filter, grep, group, not group, for each, count, average, right, and store. These are the things we have seen today. So tomorrow we will be seeing something called nested for each, co-group, joins, right? Few more are there. We will be seeing them. Okay, are distinct. You guys can try them. They are very pretty easy. You guys try them. So by going through that Java Apache big document, you can find yourself. Okay. So anyway, we will discuss tomorrow rest of the things. Clear, guys?
Okay, Ravi. Okay, Ravi. Thank you.
Yeah.